Good morning, participant, and the today resource person, Dr. Arijit Roy. Before that, as of today, we have a eminent the speaker, Dr. Arijit Roy, scientist G and head the Disaster Management Skills Division, Indian Institute of Remote Sensing ISRO, Dehradun. Sir, going to talk about advanced remote sensing tools and techniques for disaster management application. So before start of session, I request Basaraju to give a brief introduction about the speaker.
Very good morning to all. I'm very happy to introduce Dr. Arijit Roy, the resource person for today's morning. So Dr. Arijit Roy is a scientist in Indian Institute of Remote Sensing, Indian Space Research Organization, Dehradun. So he is presently head Disaster Management Studies Department at IIRS. Dr. Roy has completed his PhD in botany with specialization in restoration ecology from Banaras Hindu University, Varanasi, India. So Dr. Roy has been working in the field of geospatial technology at different centers of Indian Space Research Organization since 2004. His research interest is in remote sensing of environment, geospatial modeling of impact of climate and anthropogenic forces forcing on the terrestrial ecosystem, mainly the structure and functioning. Impact of climate change and anthropogenic influence on natural disaster and forest or wildland fire ecology and risk or damage assessment. Dr. Roy has used temporal hyperspectral satellite data to assess the spatial variations in ecosystem level processes and flows, especially of nitrogen. So he has guided more than 25 MTech dissertations and has supervised 5 PhDs. So Dr. Roy has more than 100 publications, which include 56 peer-reviewed journal publications, 22 peer-reviewed international conference papers, and has authored one book and numerous book chapters and technical reports. So Dr. Roy also holds the additional position of Program Coordinator, Center of Space Science and Technology Education in Asia and the Pacific, which conducts capacity building and education in various aspects of space science and application in association with different centers of Indian Space Research Organization. So we are very happy to have you as our resource person, sir. I welcome you again and I request you to take over. Thank you.
Thank you very much, sir, for the nice introduction. So, good morning, namaskar, and greetings from IIRS Dehradun. So today I'll be talking about what are the advanced space technology which are used for natural hazard and disaster risk management. I'll be focusing mainly on the geospatial tools and technologies which are used. So before I start, I will just like to put focus on various terminologies and the definitions which we use generally when we talk about natural hazard or natural disaster, like hazard, exposure, risk, vulnerability, disasters, etc. And when we per se talk about natural disaster or natural disaster risk management, it mainly focuses on the society or the population and also the various components of the society on which we are dependent on, like infrastructure, dwelling, the various resources we require, like energy security, food security, water security, or health, ecosystem services, the economy, the communication. It's all lot of things on which the society depends on, which are influenced by the natural disasters. So if we take into account the various terminologies which we use for natural disasters, the four major terminologies which come to our mind are hazard, exposure, vulnerability, and the risk. So when we talk about hazard, it is basically the disruption or the loss to the society or the population due to the unexpected event. Like, flood, cyclone, earthquake, etc. If we talk about exposure, it is the component of the society which is affected by the natural hazard. People, property, infrastructure, etc. And then we come to the term the vulnerability. It's basically the ability or the inability of a community to resist hazard. For example, if a community is economically stable, say like Japan, it is able to resist or overcome the hazards much easier than the community which is not economically well off, say like Haiti. So when we talk about the various components of natural disaster management, it's basically the hazard exposure and the vulnerability of a population to the various natural disasters is what we know as the risk. And this we have basically taken from the, adapted from the open-ended intergovernmental expert working group on the various indicators and terminologies which are related to disaster risk reduction. So if we see our world, how the spatial distribution of the natural disasters are there. And if you see it, it's mostly in the areas which have a high population density. So the hazards are all concentrated on the areas which have high population density, like the Yellow River Basin, the Gangetic Delta, the Europe, the regions on which the entire world is dependent on for energy security, like the Middle East, the areas like Florida and other places of United States, Mexico, and the entire Andes and the seismically active regions of the rock, starting from the Rockies and going down up to Andes in the Latin America. And if we see what are the major components or major types of disasters which are prevalent mostly in the Asian region, it's basically most of the areas it is flood. But in some of the regions like East and Northeast Asia, it's mainly the Japan and the other places which we also know as the Pacific Ring of Fire, earthquake plays a very, very important component of the disasters along with storm surges. So when we talk about disaster management, the formalization of the disaster risk management framework was in 2005 as part of the Hugo framework. Yes, someone is speaking, would like to ask some questions. If you don't want to ask any question, kindly mute your mic. So when we talk about the disaster risk management framework, it was in 2005 as a part of Hugo framework of action that we identified the three components of the risk disaster risk management, mainly disaster risk identification, risk reduction, and risk transfer. And this was to be done by the cooperation between the various governments and organizations through information sharing, education, and training. And the three verticals which were identified were risk identification, which basically meant the analysis and assessment of the historical hazard data for identifying the trends, identifying the exposed assets and their vulnerability, and also the quantification of the risk. When we talk about risk reduction, it's basically two aspects. One is the preparedness, through early warning system, emergency planning and response capacities. And the second one is the mitigation and prevention, which involved developing long-term or medium to long-term sectoral planning, such as building resilient infrastructure, etc. And the third component was the risk transfer through various bonds and alternative risk transfer mechanism. So after 2015, we had the Sendai framework. It's the same town which was destroyed by the 2013 tsunami in Japan. And in fact, in 1 year, the devastated city. In fact, this was a city which was, you might have seen the photographs of a big boat sitting on top of a small house. So this city was up and active. It was so resilient. So as a salute to the people of Sendai, the United Nations conducted this meeting of all the stakeholders. I think it's 173 countries in Sendai to develop the next 15 years roadmap. So as part of the Sendai framework, the Committee of Nations aimed to achieve a substantial reduction of disaster risk and losses in lives, livelihood, and health in various aspects of the components of society. And they had a number of goals, that is to prevent new and existing disaster risk through implementation of various policies, various methodologies and technology, so that the exposure to hazard and the vulnerable populations can be more prepared for the incoming disaster and also have preparation for response, recovery, and have a good resilience. So as part of Sendai framework, 7 targets were identified. That is to reduce the mortality due to disasters, reduce the number of people affected due to disasters, reduce the economic loss due to disasters, and to reduce the critical infrastructure and to develop critical infrastructure. And all of these were to be done through increased international cooperation, disaster risk reduction and strategies, and early warning and risk information systems. So to achieve these 7 targets, 4 priorities of action were identified. So as a scientist or a technologist, what do these priorities of action mean? So the first priority of action was understanding the disaster risk. It basically translates to like physical basis of disasters or the science behind the disasters. The second priority of action was investing in disaster risk reduction for resilience. So this investment was for the various infrastructure for disaster risk reduction, both space-based as well as ground-based. Third was to strengthen the disaster risk governance to manage disaster risk. So when we talk about governance, it's basically timely dissemination of information. So this information about the disasters, the extent of the disasters, where and how much, all of this had to be disseminated in real time to the decision makers to have a better governance for managing the disaster risk. And the fourth one is the enhancing disaster preparedness for effective response and recovery, rehabilitation, and reconstruction, which roughly translates for us technologists is developing robust early warning systems and logistics. So if we see the Sendai framework monitoring at a glance, the targets which were, as you have seen, that it substantially reduced the global disaster mortality, substantially reduced the number of affected people globally, substantially reduce the direct disaster economic loss in relation to global GDP, and substantially reduce disaster damage to critical infrastructure and disruption of basic services. And this was to be done through increase in substantially increase the number of countries with national and local disaster risk reduction strategies by 2020. Of course, we are still developing and doing it, and it's at various stages of achievement. Then substantially enhance the international cooperation to the developing countries and increase the availability and access to multi-hazard early warning systems and disaster risk information and assessment by the people. And all of these are integrated with the Sustainable Development Goals, which has been formulated by the UN. So if we see the linkages between the Sendai framework and Sustainable Development Goals indicator systems, so many of the disaster risk reduction framework or Sendai framework, the targets, are actually integrated into the various Sustainable Goals, Development Goals targets, like A, B, C, D, E, A, B, C, D, which are basically to reduce the various economic and disaster losses, are all integrated into the Goal 1, Goal 11, and Goal 13. So if we talk about the geospatial technology, which we use basically for disaster risk management, it involves the entire gamut of the geospatial technology, starting with remote sensing, GIS, GPS, ICT, which we all know about. Along with that, we are also integrating the various methodologies or space-based technologies to increase the bandwidth, ALTM, the various photogrammetric suits, the various total stations, LBS, and all this information actually is converged to produce the total turnkey solution, which provides the cutting-edge technology for disaster risk management. When we talk about the ISRO's disaster management support program, we have an institutional mechanism. So we have a decision support center at National Remote Sensing Center, which is associated with its nodal agencies like Ministry of Home Affairs, Prime Minister's Office, MOA, Cabinet Secretariat, National Disaster Management Authority, NIDM, state agencies, and NGO. And this decision support center monitors the various natural disasters and also does damage assessment. It is responsible for maintenance and updations of a national database for emergency management, that is NDEM. This also supports VSAT-based VPN for emergency communication, which has the capability for both data as well as voice and video. Then we are the Decision Support Center of the Disaster Management Support Program is also working in strengthening the various early warning systems, tsunami, flood, cyclone, drought, and landslides. And they are involved in development of hydromet networks and DSS. Apart from that, we are also developing various cutting-edge technologies like airborne synthetic aperture radars, the various communication system, various supporting IoTs, TWs, and also developing a constellation of Earth observation satellite for continuous monitoring for disaster management. The key areas for various R&Ds are landslides, earthquake, precursor studies, extreme weather events, forest fires, the entire gamut of natural disasters. And we also have the various international commitments. As we see that ISRO is, or through Government of India, is a part of the International Charter on Space and Major Disasters. And we are also part of UN SPIDER and Sentinel Asia, which provides space-based disaster management support to any of the nations across the country. So when we talk about another aspect which actually influences natural disasters, it's the climate change. And it's basically the weather and climate events and the vulnerability, exposure as a result of this to the society and the community, which influences the disaster risk. And this disaster risk basically is associated with the development. So which actually identifies the disaster risk management through climate change adaptation. If we talk about space technology in disaster management, it's basically a association of three aspects of space technology. One is the Earth observation, and it's the Earth observation basically for information. And this information is required for effective decision making. And second is the satellite-based location service. So in case of a disaster, we need to know where and how to reach there. In this aspect, satellite-based location service plays a very, very important role. And the third aspect is the communication, satellite-based communication. Because in event of disaster, first thing to be knocked off is the terrestrial communication system. So in that aspect, satellite-based communication plays a very, very important role to provide the information or to disseminate or transmit the information about the extent, intensity, and the amount of or type of rescue and rehabilitation efforts which are required, relief efforts which are required. So this actually is used for all the aspects of disaster events. So in case of a disaster, first to be required is the relief. And for that, we need to know how to send it, from where to send it, and through which route to send it. And we also need to know what actually is required, what sort of relief is required. Then we also need to identify the damaged areas and areas for rehabilitation and reconstruction. And finally, using space-based satellite Earth observation, we need to identify various mitigation methods and develop early warning systems for preparedness. So if we talk about the potential for space technology, you see, only few countries have the access or ability to develop or make satellites, but the benefits of this can be reaped by all the humankind. So basically, satellite images do not see the boundaries. And what actually they provide, especially for disaster management, is all that I have been talking about, including various research like atmospheric chemistry and pollution. When we talk about satellite orbits, there are two types of satellites. One is the geostationary Earth observation satellite, and other is the polar sun synchronous satellite. So the geostationary Earth observation satellite is at a height of 36,000 kilometers above Earth, and its rotation around Earth is synchronized with the revolution around the Earth is synchronized with the rotation of the Earth. And so that it seems that it is stationary over a particular area of the Earth, mainly at the equator. These satellite orbits are always over the equator. The second one, which is going from the pole to pole, is a polar sun synchronous orbit. So this is at a height of between 500 to 900 kilometers above Earth, and they are able to monitor or map the Earth's surface at a much higher resolution, but it is mostly in a strip mode. So these two sets of satellites are able to observe the Earth's surface in various forms. And they have a suite of resolution ranging from 1 kilometer every 15 minutes to around less than a meter at a much higher or a much coarser spatial temporal resolution. So different types of satellites are actually used for observing different areas of Earth, like the land and water resources, through various satellites like ResourceSat and ReSat series of satellite, high resolution imaging through Cartosat series of satellite, the ocean monitoring through OceanSat, SARAL or SCATSat, and weather and climate through the geostationary imaging satellites like INSAT, 3D, 3DR, Kalpana, etc. And these satellites helps us to observe and study the Earth's surface for deriving various information like the global level information from the highest temporal resolution satellites, a core spatial resolution from the large swath satellites like MODIS, a medium spatial resolution like LIS-3 or TM, or presently Sentinel series of data. The satellites provide local level information, and for assessing the location specific information like building or infrastructure, we have the high spatial resolution data. Apart from that, satellite also provides the digital elevation model to identify the terrain parameters. And these terrain parameters are done through 3D imaging capability of remote sensing. So it's basically a satellite which can image from two angles, and these two images are digitally digitally modified to provide the 3D view of a particular area. So when we talk about natural disasters in India, India is actually vulnerable to the entire range of natural hazards like flooding, cyclone, drought, extreme heat waves, landslides, wildfire, earthquake. You just name the thing and it is there. And this provides sheer vulnerability and risks. So many studies have shown that the result of climate change, the intensity, duration, and frequency of the weather-related shocks are likely to increase. And if you see the vulnerabilities and risks, especially in the Indian subcontinent, it is basically the Gangetic Plains and the area of the delta, especially the Bihar, the eastern coast of India. These are the areas which are at extreme risk for multiple disasters. So what does geospatial technology provide us for monitoring of disasters? If we talk about the remote sensing, which is a component of the geospatial technology, it helps us to have an temporal observations of the various patterns in the Earth's surface, which includes the land use, land cover, the various lithological structures, or even the hydrological structures. And these temporal observations and patterns basically help us in scientific understanding of the Earth's surface through development of various maps like hydrological maps, geomorphological maps, lithological maps, structural maps, land use, land cover maps, forest maps. So all these scientific understanding of the spatial distribution of the various objects on the Earth's surface of various characteristics of the Earth's surface is possible. And once you have all this information, one over the other, it helps us to develop the various models and processes which help in forecasting the various aspects. Now let us talk of various disasters. So when we talk about disasters, the first thing which comes to our mind is the geological disaster. And when we talk about geological disasters, earthquake is one of the most spectacular geological disasters. And Earth observations provide a lot of, or the space technology provides a lot of inputs in understanding this sort of geological disasters. So I'll just differentiate it between two aspects, like one is the observation and monitoring of the disaster, and the other one is the early warning system or risk analysis. So when we talk about earthquake, during earthquake, what happens is that there is a change in the surface of the earth. There is either a subsidence or a upliftment of the surface of the earth. And interferometric SAR actually helps in detection of these changes, minor changes on the surface of the earth. And the intensity of these changes actually identifies the areas or the extent of damage to the areas because of the tremor. Apart from that, as a result of earthquakes, there are different geomorphic elements which are forms like faults, folds, etc. So Earth observation system can help in identifying the areas of the various geomorphic elements. Apart from that, during earthquake, many a times there are thermal anomalies. So now what is a thermal anomaly? What happens is that because of the tectonic movement, the lava actually comes in contact with the underground hydrological systems or underground water, which are become a superheated steel and are released from the surface of the earth. And you have these sort of thermal anomalies in those regions. So these are the aspects of observation or monitoring the impacts of the earthquake. Apart from that, we have different other aspects. Like we have the high definition or very high accuracy GPS, which are used for constantly monitoring the movement of the plates. These are known as CORS, continuously operating reference stations. So this network of CORS are across the world, and this helps us to identify the rate direction of the movement of the various continental plates. So it's basically as a result of this study, we have been able to identify that the Indian plate is actually not moving north. It is moving at a northeast direction. And apart from the northeast direction, it is also moving at an anti-clockwise direction, which actually helps us to understand that in the Himalayan region, which are the region which are most stressed and which are the region which has a less amount of stress because of the tectonic movement. Another area of earthquake precursor studies are the anomalies in the total electron content in that ionosphere. So what has been observed is that before a major earthquake event, there have been anomaly in the total electron content in the ionosphere. And this has been observed continuously across the world. But the problem is that the resolution is very, very coarse. So this TEC anomaly, the resolution of the TEC data is around 200 kilometers by 500 kilometers, which actually do not help in identifying the exact location of the earthquake. So this is still in an experimental phase. Then we have the other geological disasters like landslides. Here also, the observation and monitoring can be done very easily through Earth observation systems. And the landslide scars can be very well identified using multispectral satellite data. But that is not all. Based on the landslide intensity, the soil structure, the slope stability, and other things, we can develop a landslide hazard map, which helps in also forewarning and risk analysis of a particular area prone to landslides. In fact, one of the very recent landslide or rockfall induced disaster happened in Chamoli last year. So actually what happened was that this entire ice mass is a hanging glacier, which was here, fell down. And this is the area which you see is gone from here. So this entire mass fell down around 2 kilometers to the base of the valley, where it actually melted the entire snow and permafrost, which resulted in the slurry which damaged the downstream area. So this is the Tapovan hydropower site which was damaged, and in this place more than 250 people died because of this flash flood. So you can see the height of the water or the slurry which was created as a result of this event. So this is the pre-damaged vegetation, and this is the post-damaged vegetation, and these are the individual trees which you are seeing. So the entire wave was something like this high, which was it was around 40 to 50 storied high wave. Then we have the flood monitoring, and flood monitoring is done basically using microwave data. Because as we all know that in Indian region, the floods are generally during monsoon. And when there is a flood, the cloud is covered, the sky is covered by clouds. And microwave data has the capability to penetrate through the clouds because of the larger wavelength and provide the information on the inundated area, because of the variations of the dielectric property of the flood. So we have the various observation and monitoring. And I'll just give an example of the work which we did for Kerala in 2018 when we had that Kerala flood. So we could identify even during the clouded period the areas which were inundated as a result of the flood. And it's not just the inundation, but the duration of the inundation could also be identified. Apart from that, we have the early warning and risk analysis, which actually are because of the various models which we use, we are able to predict the amount of rainfall which can occur in a particular area. And based on the model-based as well as Doppler radar-based rainfall inputs, we can develop the hydrological models to generate the river hydrodynamics, that is the amount of discharge. And based on this, we have a pre-computed flood map library which can provide in near real time the flood situation. This actually is being used for the Brahmaputra Basin as an operational project. Apart from that, we have the various other hydrometeorological disasters like extreme weather events and flash floods. And this, when we talk about extreme weather events, they are like they are actually the cloudburst, what we call in the northern Himalayan region. These are very high rainfalls, amount of rainfall, something like more than 100 centimeters in just of 1 hour. So if you have this sort of rainfall, it is actually like the entire water mass is being poured, and the amount of rainfall, amount of water generated washes out everything in its path. It's a localized area event, mostly in the Western Himalayan region. So using the satellite based precipitation data from TRMM, we have been able to analyze the areas prone to the cloudbursts. If we talk about the flash flood, which is a result of this cloudburst, one of the most what you call newsworthy event was the Kedarnath flash flood, in which more than 15,000 people actually died. So Earth observation can be used to identify the damaged areas of the during flood, but more than that, it also provides inputs to rescue and relief. And I'll tell you how. So this is the first helicopter flight. The video you see on the screen is the first helicopter flight after the clouds had cleared from the valleys and helicopters could fly. And then the actual rescue could be carried out. So what had actually happened in 2013 was that there was an extreme rainfall during 15th to 17th of June, which triggered a number of landslides. And the extreme rainfall over the Chorabali and Companion Glacier actually washed off all the debris of the glacier into the Chorabali Lake, which got breached, and the entire flood and devastated the Kedarnath town. So before this helicopter could fly, we had already created a digital fly-through using satellite data and digital elevation model to actually identify the damaged areas. And this was the input which was given to the Indian Air Force for them to plan their flights in case there was a low visibility in the Kedarnath Valley. Then we also have the other hydrometeorological disasters like drought. Here also Earth observation helps in various monitoring like frequency. Then we can monitor using NDVI the crop conditions, the soil moisture, etc. To basically identify the various types of droughts, mainly meteorological, agricultural, or hydrological droughts. But apart from this, we have also developed an operational early warning and risk analysis for the drought systems using a combination of satellite-based as well as ground-based information, including the weather forecasting, to identify the area-specific vulnerabilities of the crops to the drought. And this is also used for moderating the price trend of the food and feed. So these drought early warning systems provide the time of occurrence, the spatial extent, the duration, and the severity of the drought. Then we come to the various coastal disasters. One of them is a tsunami. Tsunami is basically an underwater earthquake, which provides, which creates a ripple on the surface of the water. And when this ripple moves towards the coast, it causes huge waves, which actually devastates the entire land area. So using Earth observation system, we can do the monitoring of the damages, and the space-based technology play a very, very important role in an early warning system for tsunami, which is operational at INCOIS in Hyderabad. So this consists of a network of special pressure sensors which are installed at the bottom of Bay of Bengal, And these pressure sensors are connected to the GPS buoys, which in turn have the satellite-based telemetry to communicate the information picked up by the sensors directly to the simulation center at INCOIS. So moment there is an earthquake, the sensors pick up the information and relays it through the buoys to the INCOIS. And INCOIS has already made more than 90,000 simulation of various intensities and locations of the earthquakes across Bay of Bengal. And it picks up the best suitable simulation and provides the warning almost within a few minutes of getting the information. The warning is sent through radios, mobiles, as well as loudspeakers to the coastal community. It's not just in India, the information is also sent to the other Bay of Bengal countries like Indonesia, Myanmar, and Singapore, etc. Among the other coastal disasters are like sea level rise, which results in the incursion in the saltwater incursion into the aquifers. Then the inundation because of the sea level rise, as well as the various upwelling due to the storm surges. One of the most devastating coastal disasters are the cyclones. And Earth observation provides a very, very important tool for the observation and monitoring of the cyclones. So the cyclones provide, cyclones actually happen because of the changes in the sea surface temperature. And present Earth observation system, like our own INSAT 3D, 3DR, are able to monitor the cyclone right from the time of the cyclogenesis by studying the variations in the sea surface temperature. And once the cyclone is formed, it is monitored constantly through various systems, both land-based and sea-based, and also tracking the cyclone and identifying the landfall of the cyclone. In fact, if you remember, in 1999, we had the Odisha super cyclone, in which more than 12,000 to 15,000 people died. But after that, a lot of investment had been made for both Earth observation-based as well as ground-based to basically monitor the cyclone. So in 2013, we had the cyclone falling. And this was monitored through various satellites like INSAT 3D, 3DR, and OceanSat for the cyclogenesis as well as tracking its movement. And this cyclone was even bigger, or had was of more intensity than the 1995 great Odisha super cyclone. But in this case, since people knew about the landfall, people could track the cyclone, and we had all the prior information, the number of casualties were in single digits. So this is the power of information in saving life and property. Apart from that, GIS techniques has been used extensively for disease surveillance and human health. For example, mapping the malarial infested regions in the across India, having a biosurveillance network, tracking the COVID-19 status across the country, etc. Then we come to the various environmental hazards like heat wave. In fact, Earth observation system, wherein we have the temperature sensors, provide beautiful information on spatial variations in the heat wave hazards across the country. And it also has helped us to study the various causes and reasons for the spatial distribution of the heat waves, like the land use, land cover, and how the various populations are at the vulnerable to the heat wave events in the different parts of the country. So we could create the heat wave hazard maps as well as develop a heat wave risk map for the Indian subcontinent. Then we have the other environmental disasters like forest fire. Here also Earth observation plays a very, very important role in all the aspects. The thermal data can very easily detect the active fire. And this is an operational activity which is done almost 6 times daily. And using multispectral satellite data, especially the shortwave infrared, we can detect the burnt area because of the changes in the moisture content in the soil. Then we have used Earth observation systems, especially the various weather-related characteristics which can be mapped. So using the various weather input data from the satellite as well as from the ground-based sensors, we have developed a forest fire risk advisory and monitoring system, which provides a daily information of the potential risk areas to forest fire for the next 24 hours. These are complex models which have actually helped in developing this. This entire thing is operational for Uttarakhand, and we have this is monitor what is called calibrated for the entire Western Himalaya. Another aspect is the forest fire spread, which you see in the lower bottom. So this involves a number of models like WRF, graph theory, connectivity models, as well as cellular automata to develop in real time that once a fire has occurred, how it is going to spread in the next 24 hours. And this information is very important for the forest fire managers to control the fire activities and its spread. Apart from that, for the decision makers, we also need to help them to identify through a survey about the extent of damage. And this is as a digital fly-through of the Uttarakhand state during one of the fire episodes in 2019. So you can see the area which are being devastated by fire, which have been burned by the fire, etc. Apart from that, there are various other models which can detect the black carbon and also track the atmospheric pollution and its movement across the landscape. In fact, we have been able to identify the actual root cause for the Delhi air pollution. And it's not because just because of the crop residue burning in Punjab and Haryana, but the crop residue burning actually enhances or exacerbates the dust which flows from the Pakistan-Afghanistan border across the Punjab plains and comes to Delhi. Then the various drone-based hyperspectral data can be used for identification of gas leaks in pipelines. High-resolution satellite data can help in identifying the various hazardous waste dumps and their various hazard conditions. And also we have the various microwave data which can detect the oil spills in the sea. Then we have the climate change, which are actually causing the various natural disasters. So based on the Earth observation system, we can monitor the inundation of the areas which are at risk from the climate change impacts, mainly like the islands like Maldives, which are just a few meters above the sea level. There is another aspect of climate change, which actually we ignore a lot. It's basically the large-scale singular events. So It has been predicted by the IPCC that the northern hemisphere sea ice extent is going to disappear by 2100. So once this happens, once this event happens, then what is the impact? Yes, please. Can you please mute your mic? So we have the various ocean currents across the globe, which helps to maintain the climatic conditions as we see today. So one of the warm currents is the Gulf Stream, which you see which you see goes from the Gulf of Mexico here to the north of Europe. So once and when it goes to Europe, it actually meets the cold water from the northern ice-capped Arctic Circle and increases in the density and goes down. So the amount of water which actually goes down, almost like a waterfall, is every hour is more than all the water contained in all the rivers and all the lakes across the terrestrial ecosystem. So this actually helps in the circulation of the model and keeping the Europe as it is now. So once this melt, this is going to change the thermohaline conditions in the Northern Ocean. And this entire water mass which goes down, this entire conveyor belt may stop. So once this happens, there is going to be a huge repercussion. Hello? What? Please hold on a second. Hello? না আমি করিনি, আমি একটা লেকচার দিচ্ছি, আমি একটুখানি পরে করব। So this will change the thermohaline conditions and will once this conveyor belt stops. In fact, this is the warm current which keeps the Europe ice free throughout the year. Because if you see the latitudinal extent of Europe and Greenland, you see it's almost the same. Whereas Greenland is perpetually covered by ice, but Europe is ice free, is because of this warm currents. So if they stop, almost half of Europe will be under ice, and the civilization which we know will change permanently. Apart from that, we have the satellite navigation systems like IIRS and Gagan, which helps to actually reach to the place where we have the disasters. As part of this satellite navigation system which we have developed, we have an added feature. So this actually was as a part of an accident which we did. So during 2017, there was a cyclone Oki in which 70 fishermen from Kerala lost their lives. And they lost their lives because this cyclone was formed south of Sri Lanka and moved towards Kerala. And the fishermen who had already gone out to the sea could not be alerted about the impending disaster. So after this event, the Kerala government approached ISRO to develop something which can be used to warn the fishermen who had gone out into the sea. So one of the satellites of IIRS had the ability to send text and receive text message or transmit text messages. So ISRO developed a device which could connect to the mobile phones of the fishermen through a Bluetooth. The device was attached to the mast of the ship, and the information could be sent from the coast. That's the control center in the coast about all the impending disasters to the fishermen. In fact, this has also been used for geofencing, so that the fishermen inadvertently do not cross into the waters of other countries. And we also space-based communication system is basically a satellite-based virtual private communication network, or VPN, which is used for disaster management support and also connect to the various parts of the country. So this has a one hub station at the Ministry of Home Affairs in New Delhi, which is the primary node, and have user nodes spread all across the country at every district. So this has the capability to provide voice, data, and video traffic between any two nodes. Then if we talk about satellite communication, during disaster, this VPN is also used for telemedicine, because many of the areas where the disaster happens will not have access to the specialized doctors. So this is used for giving specialized healthcare to the affected people across the country. A very recent development in geospatial technology is also the crowdsourcing. So during 2015 Chennai flood, the crowdsourcing technique was used to actually direct the relief and rescue for the people who were in the need. And this was also used to develop the database on the impact of the Kedarnath flood. So using around 150 students from 3 universities with a small app loaded onto their mobile phones, we could collect the information on the type of damage and all the impacts at every places for the area. And in 3 months, around 19,800 samples were collected across the state. Then the national database for emergency management is hosted at NRSC and provides the information for emergency services in case of disasters. So this has a disaster dashboard, incident reporting, data visualization, decision support tools, interaction portal, resource management, and all the aspects for disaster management inbuilt in it. And the tools which are provided are like proximity tools, network analysis. The user can upload a particular data and also do a multi-layer analysis to arrive to a particular decision. As part of our international commitments, we are part of Sentinel Asia, which is an initiative by the Asia Pacific region, and provide the space-based inputs in case of emergency to the member states. And we are also a part of International Charter for Space and Major Disasters, so which is a mechanism which provides space-based information for disaster response across the world. Thank you very much. So with this, I come to the end of my presentation.